Hello everyone. Today I'll introduce you our paper about device-free gaming with the mmWave radar. Now interactive games are appearing in public places such as airports and other shared spaces. They can make waiting time more fun and they create a more engaging cockpit environment. But there is a problem. Many existing systems rely on either handheld controllers or cameras. Well, controllers are not ideal in busy public spaces because many people need to touch the same device, which leads to hygienic issues. Also, cameras are problematic. They capture identity-rich information, especially faces. And today, with powerful AI models, facial and appearance data can be used in ways that people may not expect or want. So this raises an important question. Can we support interactive gaming in a way that is both contact-free and more privacy-friendly? It turns out that the millimeter wave radar can be one of the solutions. Unlike a camera, radar does not capture appearance. It does not record facial details, clothing texture, or other visual identity cues. Instead, it senses motion and body structure in a much more abstract way, mainly as sparse point clouds. So mmWave gives us an interesting trade-off. It can still sense how a person moves, but it reveals much less personal visual information. That makes it a promising option for privacy-aware gaming in comic spaces. But using a radar for gaming is not automatic. To make a game playable, the system has to do several things well. First, it has to know where the player is. That is the tracking task. Second, it has to know what the body is doing. That is the post estimation task. Then, the game engine must turn that motion into control in real time. So the real question in this work is not just whether radar can sense motion. The real question is, can mmWave support real interactive gaming with enough accuracy, enough smoothness, and low enough delay? To answer this, we did three things. First, we benchmarked state-of-the-art tracking and post-estimation method under one unified framework. The second, we built a full gaming system, including our controller pipeline and four Unity games. The third, we evaluated the system in two ways: objectively with motion analysis and subjectively with the user study. After benchmarking, we selected RKF for tracking and MMS for post estimation as the best balance for gaming. So this is not a sensing study only. It is a full pipeline study from radar input to real gameplay. We designed four games with increasing control complexity. The first one is Breakout. This is the simplest case. The player mainly moves left and right. The second is Space Shooter. Here the player moves in two dimensions, so control is a bit richer. The third is Tennis. Now we still need body tracking, but we also need simple arm swing actions. The fourth, the most difficult one, is Fix Saber. It needs fast and accurate arm pose estimation, plus the smooth motion. So together, these four games let us test the boundary of what mmWave can and cannot do for interactive gaming. Now let's look at the main results. For Breakout, the experience is good. Body position is tracked well enough, and the motion is fairly smooth. For the Space Shooter, the result is actually the best. It is accurate, smooth, and also more fun because the movement is richer. For Tennis, the result is acceptable. The system can respond to most arm swings, so the game is still playable. But for Beat Saber, the result is limited. Players can clearly feel a gap between their real motion and the in-game motion. So the overall message is clear. mmWave already works well for the simple games and it cores body control, but it still struggles when the game depends on defined arm motion. So why does this gap appear? There are mainly two reasons. The first is arm pose accuracy. Well, tracking the body center is relatively easier, but reconstructing elbows and wrists is much harder, especially when the arms move quickly, overlap with the torso, or move in challenging directions. The second one is the frame rate. Operator runs at about 20 frames per second. Modern games are, however, much faster than that. We use some upsampling tricks to make the motion look smoother at 60 frames per second, and this helped. But upsampling cannot fully recover motion details that were never captured in the first place. Also, when the estimation in 20 frames per second sequence is already in low accuracy, the upsampling can make it worse. The final takeaway is this: the mmWave radar is a strong option for privacy-friendly device scaling, especially for simple games. It already works well when the game mainly depends on player position or course gestures. But to match camera-based system in more demanding games, we still need progress into areas. We need better arm pose estimation and higher radar frame rate. In other words, mmWave is already promising today, and it can become much stronger with better hardware and better models. Thank you very much for listening.